Okay, in this video we're going to have a look at acids and bases and a bit of introduction to the basic ideas that we need to understand. Okay, you should be familiar with this. This is the pH scale. I've not put all the numbers in, but I've put the key numbers in just to help us. So here we've got a pH scale goes from 1 all the way up to 14. 1 to 6, they're categorized as the acids. 7 in the middle here is neutral, and then 8 to 14 are broken up into bases. Within this, we can do a further split with pH 1 being identified as what we call strong acids. More on that later. pH 6 we're going to look at as weak acids. 7 we've already said is neutral, and then the bases, pH 8 is a weak base, and pH 14 is a strong base. Okay, let's have a look then a little bit more at each of these in turn. Let's take the acids first. And what I'm going to do here is I'm going to use the notes from your workbook to help me to do this. I'm going to pull this across. So in your workbook you have this table. Okay, and this table is giving you some examples of some common acids. So here we've got hydrochloric acid, HCl, nitric acid, HNO3, and sulfuric acid, H2SO4. Hopefully, the first thing you notice is what do they all have in common, and the key part of the acid is they all contain hydrogen, and that's what we're going to use to help us define the acid. We're now going to look at what happens when they dissociate. We need to understand what the word dissociate means. Dissociate is to do with separating into ions. So you're going to split the formula into these separate ions. So, for example, HCl will form H plus and Cl minus ions. HNO3, so we take off our H plus, and that leaves us with a NO3, and that's a negative ion, which is a nitrate ion. And then sulfuric acid, notice it's H2, so we get 2 lots of hydrogen, and then what's left over is a sulfate, which is SO4, 2 minus. So all we're doing here is separating, dissociating these acids into the ions. Okay, it's worth bearing something in mind here. If I just go back to the other page for a second, is that we start here talking about the strong and the weak. When we look at these acids, if this hydrogen ion concentration, so what that means is the amount of these hydrogens that are being produced, the concentration of them, the amount of them. If the amount of these hydrogen ion concentrations increases, then our pH number will become lower. So that means it's going to move down this end in this case. Okay, let's look at bases. So I'm going to go back here to your notebook page. Now we need a definition just to help us here. Okay, and here you notice in the table it talks about an alkali. An alkali is a base, but it's a base that is soluble. So alkalis is a base that is soluble. It does exactly the same as a base would do. It has the same pH range, but it just means they are soluble. And here we've got some examples again just to help us understand this. So we're going to dissociate. Remember that means split into the ions, separate into the ions. So here I get an Na plus and a hydroxide ion. Here I split this into potassium ion and a hydroxide ion. And here I get Mg2 plus, and notice it's OH2, so we get 2 lots of the hydroxide. So what you notice in each of these is these alkalis are all separating or dissociating to form hydroxide ions, and you can see in the formula they all contain the hydroxide ions, and that again is what we're going to use to help us identify alkalis or bases. If we come back to my other page for a second, what we need to know here is that as the hydroxide ion concentration increases, so remember that means these ions forming. So as the concentration of the hydroxide ion increases, then the pH number becomes higher. So if I go back up to my pH scale, you can see what's going to happen here is as we get more hydroxide ions, this pH is going to start to increase and head towards pH 14. Now with this information, you should be able to answer the bit at the top, the fill in the gaps exercise. You should then be able to complete these tables. You can pause the video to look at them and transfer it across. You might want to add some little notes to remind yourself of some key phrases. If you get stuck, there's some little videos here that you can scan that give you a little bit more detail of what we just said. And then at the bottom of this page, you've got some questions that need a little bit more of a detailed response based on the information I've just shared with you. Okay, as I said, pause the video, rewatch the video, do whatever you need. I will put one up at the end with the answers to this so you can check your work against the answers, but please only use that once you've had a go at doing the questions yourself. Good luck. Okay, this is part 2 and the next page of your work booklet. So we're starting here again with our pH scale. Notice that all the numbers are in, and the first task is to add these labels underneath the appropriate numbers. Okay, so I've actually started to do this. So this end, remember, 1 to 6 are my acids, and this end of that scale is the strong acids, and then we head to weak. 7 is neutral, and then this end are my bases or my alkalis. This end are the weak alkalis, and as we head across, the number increases. Then we get to our strong alkalis. Okay. Underneath this, you will notice that there are then 3 indicators. So we've got litmus, methyl orange, and phenolphthalein. And what we need to be able to know is the colour that these indicators turn in the different pHs, because the indicator is used to tell us something acid or an alkali, or if it's neutral, and we need to remember the colours that they change. So let's do litmus first. Litmus in acidic conditions is a red colour, and litmus in alkali or base conditions is a blue colour. Neutral litmus is purple. Okay, so we've got 3 different colours to tell us the pH for using litmus. Methyl orange is a red in acidic conditions, and then in alkali conditions and also neutral, so it's right away across there, it is a yellow colour. And phenolphthalein, if we use this in down here, we have got that it is colourless, and that goes all the way up to neutral, so it's acids all the way to neutral. And then in pH ranges that are base or alkali, we have a pink colour. So if we use one of these indicators, we can now tell by the colour that it turns if the solution we're testing is an acid, a neutral, or base. For example, if we drop methyl orange into a solution and it goes red, we know therefore it must have a pH in this 1 to 6 range, meaning it's an acidic solution. Okay, we need to know these and remember these. Second, we need to do at the bottom here is it talks about the pH scale and the actual hydrogen ion concentration. And you've noticed each one of these, so pH 1, and it gives you down here the concentration of hydrogen ions, and then you've got pH 2 and the concentration down here of hydrogen ions, and then pH 3 and so on. You get the idea all the way up here to pH 14, and then here is the hydrogen ion concentration for pH 14. What you need to recognize in here, I've got a little sheet here to help us do this, is the following. Okay, is as you move across, as your pH changes by a factor of 1, just get this right for you, as pH changes by a factor of 1, then we end up with a situation where this concentration changes by a different amount. Let me show you what I mean. Okay, so going from pH 2 to pH 1, this is increasing by a factor of 1. Going from 2 to 1 is increasing by a factor of 1. The hydrogen ion concentration at pH 1 is 1 times 10 to the minus 1 in standard form, which is this number. And pH 2 in standard form is 1 times 10 to the minus 2 for hydrogen ion concentration, which is this number. What you notice here is that they're actually changing by a factor of 10. So what we've got here is a change in pH of 1 causes a factor of 10 change for the hydrogen ion concentration. Okay, so let's just say that again for you. The pH changes by a factor of 1. A change of 1 here causes a 10-fold, 10-factor change on the hydrogen ion concentration. Again, if I just go back to your notes, you should now be able to do the following. You should be able to complete your table here, as we've done. Have a look at this that I've shown you here about the hydrogen concentration and the link to pH. And then underneath here, on the bottom of this page, are some questions that you should be able to answer. Again, I'll do those questions at the very end for the answers so you can check yours, but please have a go first and then check them against my answers so you can make sure you're getting them correct. Okay, good luck with that part, and then there's one more part to finish us off. Okay, in this video we're going to have a look at some key terms that we use to describe acids and bases. One of them is we talk about the concentration of an acid or base. And we need to just remember, going back to our last topic, that concentration is a measure of the number of particles in a certain volume. So you have a high concentration, you have lots of particles in a volume. If you have a low concentration, then there are fewer particles in that volume. So here to help you, again, this is from your workbook that I shared with you. We have this little box here, and you can see that this side here is a low concentration, and therefore there are a few particles in here, and here we've got a high concentration and there are many more particles in this space. Okay, so high concentration means lots of particles in a certain volume, and a low concentration means there are less particles in that same volume. Underneath is a space for you to explain, so you can transfer your image into here. Underneath, explain in your own words the difference between something being dilute or concentrated in this way. The second term that you hear people use is about strong or weak acid. And if you remember on our chart at the beginning, we actually had strong and weak being defined on here. Let's just look at what it means in this way. Let me just find my piece of paper. Here we go. So strong and weak for acids means this. If you have an acid that's a strong acid, then it separates, dissociates into its ions, as we talked about in our first video. And strong acids fully dissociate. That means, as you can see this arrow, they all end up becoming H plus and Cl minus ions. So everything that was HCl becomes H plus and Cl minus ions, and it fully separates into these ions. If you have a weak acid, this here is ethanoic acid, vinegar, then you notice the arrow is different. Here we've got an arrow that's going forwards and also backwards. So this arrow is going in a two-way direction. This forms the hydrogen. Remember, all acids release hydrogen, and the ethanoate ion, the negative ion. But because this is no longer fully separating, fully dissociating, it's a weak acid. Weak acids, we say, partially dissociate. So it means that when you've got this, some of them will separate into the ions, but the majority of them will stick as this. They will not dissociate. So they only partially dissociate. So when we talk about strong and weak, this is how we're going to define them. We'll define strong acids as acids that fully dissociate, fully separate into the ions. And we describe weak acids as those that partially dissociate, and that means they don't fully separate into the ions. Some will, but the majority of them will stay unseparated in this way. Okay, again, in your notes to help with this, there's a little section here for you to do. If I was you, I would pause the video on these equations, and I'd write these equations in to give an example to show how these work, and then explain in your own words the difference between a strong and a weak acid. Okay, I will then put on videos for the answers to the other parts. You can check them all off, please. There's a homework in there as well for you to do with a mark scheme. Please do the homework and then mark it yourself. Any questions, ping them up to the teachers, and we will get back to you to help you with that. Okay, good luck everyone. Okay, in this video we're going to go through the answers to the questions from the workbook. Okay, so here we've got acids in solution contain hydrogen ions which have a pH of 1 to 6. A base has a pH of 8 to 14. A base which is soluble is an alkali. An alkali solution contains OH minus hydroxide ions. If acids and bases are mixed in the correct amounts, they will cancel each other out. This reaction is called neutralization, and the neutral solution has a pH of 7. Okay, change anything you might have got wrong, tick the ones you got right so you know they're right, really important, and hopefully that makes sense. At the bottom of that page, here's some more answers. So this one says what is meant by dissociation. So it's where the acid or alkali separate into ions. What's the common ion formed from acids? We've got H plus ions. What is the common ion formed from alkalis? It's hydroxide, OH minus ions. And then show how the hydrochloric acid dissociates. There's my equation showing dissociation. Mark those again. Anything you need to change, please do. And tick them off so you know they're right. And then on the back here, the very bottom of this page, there are some more questions. Ask you to, what is the relationship between pH and hydrogen concentration? So when the pH becomes lower, so as the hydrogen concentration, the pH becomes lower, a change in pH of 1, remember, causes a 10-fold change in concentration. Okay, so a change in pH of 1 is a 10-fold change in concentration of hydrogen ions. Strong acids have got higher hydrogen ion concentration than weak acids, and in terms of hydroxide, we've got strong alkalis, we've got a higher concentration of OH minus ions. Okay, hopefully tick them all off, that makes sense. Any questions, please let us know, and only mark them once you've done them. Don't be marking them prior to doing it or filling out as soon as you go along. Okay, everyone, good luck.